Hello, good morning. Thanks for showing up for this early morning session on the last day of conference. Got a lot of people here. We appreciate you being here. My name is Peter Czuszewski. I'm a program manager at Microsoft, and with me here is Dan Silver. He's a software engineer at Microsoft. We both work on the team that builds some of the core infrastructure for Microsoft Graph. And today we're going to talk about how you can use Microsoft Graph to automate background processes that leverage Microsoft 365 data and capabilities. We're also going to show you how you can host your application on using Azure capabilities. So let's talk about our agenda for today. So when you build a Microsoft Graph app, there's a design choice you need to make early on. So we're going to talk about the difference between what we call user interactive versus non-interactive scenarios, and we'll help you understand like what they are and how to choose between those two. We will spend some amount of time on this, but later we'll be focusing on non-interactive scenarios, which is really what you use when you build background processes. After that, Dan is going to walk us through a demo of a provisioning workflow that implements that non-interactive model, and he's going to show us some cool capabilities both in Graph and in Azure. After that, we will deep dive on what we call change tracking capabilities of Graph. This is what our demo heavily relies on to respond to data changes and events in services. So we'll help you understand the difference between Delta Query and change notifications, how to choose between those two. And at the end, we'll talk about some best practices for securing your app, which is particularly important when you're building a background process. So first, let's talk a little bit about Microsoft Graph. It is a very important piece of the Microsoft 365 platform. You can think of it as our developer experience or programmability story for Microsoft 365 services. It used to be that each service would expose its own APIs. Now we have a common API gateway, a common format for all APIs across all services. That's what Microsoft Graph is. And this allows you to create a single application that interacts across this wide range of capabilities we have in Microsoft 365. When you're building an application, there are really three broad categories of experiences that you can build. Today, we're focusing on what is sometimes referred to as daemon apps, workflow automation, or background processes. But those are basically scenarios that do not involve a specific user. You can think of apps such as a provisioning workflow or a content scanner, an app that scans content across the organization, and so on. The second category we call user-centric experiences. This is what typically people think of when they think of Microsoft Graph. So imagine apps such as an email client, a calendar scheduler, a people picker, collaboration solutions. I recommend those two talks. One of them happened earlier in the week. You can catch it on video. One is happening later today. At the end of the deck, we'll have a more complete table recommending some of the Graph talks. But if you're interested in those types of apps, have a look there. The third category that we only recently started talking about a lot is what we call insights apps or analytics apps. Let me spend a little bit of time on that. So analytics app or insights apps are scenarios where you really want to work on a bulk data set from Microsoft 365. Maybe you want to run some AI, machine learning, or some sort of analysis on your emails or other content, and you want to extract some insights. In the past, it used to be that you would have to write your own background application to do the heavy lifting and continuously extract data from Microsoft 365, put it somewhere in Azure storage, and then run your analytics. What we have recently introduced is something we call Microsoft Graph Data Connect, which is this piece of functionality that allows you to set up an automated set of jobs, point them at specific data, and it will, on your behalf, extract the data and put it into Azure storage that you control. So you no longer have to do that heavy lifting and syncing. You can just focus on implementing the actual meaningful insights logic that you want. So there will be an entire session dedicated to this capability at 3:30 today. I recommend, if you're interested in that category of apps, that you attend that. Let's have a quick look of what's behind Microsoft Graph. Sometimes people assume that Microsoft Graph is some kind of copy of data coming from the services. It is not. It's a gateway to the actual services. So all of the APIs that you see in Graph are actually implemented by the many services in Microsoft 365. As you can see, most of them are there. Office 365 with its productivity functionality, emails, calendars, teams, planners, etc. Then we have Windows 10 with its cloud capabilities, so you can program against those cloud features that Windows 10 exposes through Microsoft Graph. Then we have Dynamics 365 with its growing business data and scenarios. And then we have Enterprise Mobility and Security, which is focusing on identity management, security, device management, so products like Intune, Azure AD, Advanced Threat Analytics. As you can see here, these are what we call entities exposed through Microsoft Graph. And you see that they vary. They go from user-centric things like mail, calendar, contacts, to things that are more oriented at the administrator or the organization. For example, you can set up your synchronization from on-premises via Graph. You can control advanced threat analytics via Graph. You can access security reports. So it's a very broad range of data and functionality, not just user-centric stuff. When you develop an application, early on you have to decide how your application is going to interact with the data. And there are really two choices here. The first one is to access data on behalf of a signed-in user. So imagine an application, it could be anything, imagine an email client. It really needs a user to sign in with their own credentials and produce an access token, and only then is the application able to make API calls. So examples, an email client, a calendar scheduling bot, a people picker. Typically, your considerations there are what type of authentication flow to use. You would look at things like on behalf of, if you're architecting a middle tier, or if you're writing an application for a device that has limited input capabilities like a smart TV, you could use a device code grant to let users authenticate into those devices. We've all done that with apps on TVs, right? Where we have some code and we go to a website. We recommend you use this approach when you have a real scenario where there's a user involved. But at the same time, like I said, there are many important scenarios where there is no user. So think of a provisioning workflow that needs to do some work, even when the user has just been added to the organization. They might not even know their password. Or maybe it needs to access data across multiple users, like look at emails in Outlook, without the user being actively present. It needs to be able to do that all the time. So for those scenarios, you model your app as non-interactive, which means that it has its own credentials, and it can make calls to the API on its own. When you do that, you typically focus on things like data access controls and authorization. Like you need to think through who has access to the data and what happens with the data. You focus on documenting your terms of use, especially if you're building an application for other customers to use. You need to explain to them what data is being accessed and how it's being processed for them to be able to assess your application. And then you need to focus on securing your app credentials, because as you will see, that's what gives you access to the data. Let's deep dive on this a little bit to make it clear. So first, let's walk through a user interactive app. There's a user present, they sign in, and interact only with the data that they can access. What this looks like is that the user will consent on first use to the permissions that your application has defined. Only after that consent is granted is the app able to request access tokens, and they are user access tokens. What's important is that the effective permissions of your application when it runs are an intersection of what it registered and what the actual user that signed in has. So as an example, let's say if a highly privileged user logs into your app and your app wants to list all the users in the organization, it will receive a full set of users, the full directory of users. But if a user with limited permissions signs into the same application with no code changes, your app will get a limited set of results because the underlying service behind Microsoft Graph will evaluate what data the user should see and not see. So that's the key piece here. Let's look what the developer app registration experience looks like. So this is our new application registration portal that is much cleaner and simpler than what we had before. As you can see here, there's no such thing as an application type, interactive versus non-interactive. Instead, what we're doing is we're requesting permissions, and there are two types of permissions. We call them delegated and application permissions. So in this case, I picked two delegated permissions, which means that my application cannot do anything on its own without the user. The first time the user signs in, they will see a consent dialog explaining to them what permissions are requested, and only if they accept will the app be able to get a token. So in this example, an app is using a user's token, Lydia's token, and it's calling Microsoft Graph to access her mailbox, so emails in Outlook. And in this case, the call succeeds, and we get a full enumeration of her emails. Now let's see what would happen if we tried with the same token belonging to Lydia to access a resource that she cannot access, which is Peter's mailbox. Well, in this case, the request fails. And it fails because the underlying service, Outlook, decided that Lydia does not have access to this particular resource, and it fails the call. So we didn't have to do anything in our application to write some authorization code to do that. We just leveraged the knowledge that the service has of who has access to what. Now, for non-interactive apps, which is what we're talking about today, there is no user. The app uses its own credentials and can interact with the data on its own. The flow here is slightly different. It is the admin that consents to the permissions that the app requires. Those permissions typically affect the entire organization. So if we look at files read all, that means the app can read files in every SharePoint site in the organization. Mail.read means it can read emails in all mailboxes. So that's some pretty powerful stuff. That's why the admin has to consent to that happening in their tenant. Once that happens, the app can authenticate on its own. And the effective permissions are the full level of privileges that the permissions describe. Again, registration, in this case, I'm asking for two permissions that are of type application. And the portal gives me this useful hint that says, OK, for these, admin consent will be required. If I want to quickly test this application in my own tenant, I can consent, if I'm an admin, right here in my tenant and start calling APIs. But in a real-world scenario, especially multi-tenant, I would have to provide a link for each administrator in every tenant to consent individually. And only then my app can use the authentication flow here to obtain tokens for that tenant and start calling APIs for resources in that tenant. So the similar example, the difference is that the application is using its own access tokens, and it can request any mailbox in this case. We strongly recommend that you let your scenario drive your design decision. So if you do have a user interacting with the data, do use the delegated permissions and the corresponding user authentication flows. You will benefit from our services enforcing access to data. And avoid using application permissions in these scenarios because you might expose more data to the user than they're supposed to have. However, if your scenarios are different, by all means, go and utilize application permissions and the application auth flows, and focus on securing and managing your credentials. We'll give you some best practices for that, for example, using Azure Key Vault. And also consider documenting terms of service for admins to understand what your application does. Even if the application runs within your own company, that is important. Let's go through some good and bad design choices for each of those. So first for interactive scenarios. And I'm using a simple email client application here. As we see, user signs in with their credentials, and the client app can call Graph directly. So it's all good. But let's say that we wanted to create a middle tier API because we want to have some business logic running in the middle tier and not on the end user client application. So the correct way to do it is to obviously have the user sign in and get an access token for the middle tier API that we exposed ourselves. But the next thing we want to do, we want the middle tier calling Graph and interacting with the data. So in this case, what our middle tier does, it uses the original token and exchanges it for a token for Graph, but it does it using the OAuth on behalf of Flow so that those delegated permissions from the user are still maintained, and our middle tier cannot access more data beyond what the user is supposed to do. A bad example would be one where our middle tier authenticates the user, but then it kind of drops the original user token, and instead it uses its own application permissions to request its own token to call into Graph. So what happens here is that it's able to access data beyond what the user can see, and it's in a difficult spot, our middle tier, because it's now responsible for correctly authorizing data to access to data. I'll use an example. In Outlook, there's a concept of shared mailboxes. These are mailboxes that many people can use. For example, they're attached to office groups or teams. And Outlook knows which user has access to which shared mailboxes based on access control lists, group membership. It would be very hard for our middle tier to know that. It's probably impossible. In this flow, Outlook will give it to us, but in this flow, it won't. So it'll be up to us to make sure that we're not by accident accessing some shared mailbox that this particular user is not supposed to see. So that's the reason to do that, to implement it these two ways and not the third way. For non-interactive scenarios, it's simpler. Let's say our app in this case is a provisioning workflow, has its own credentials, calls Microsoft Graph. An incorrect way to do that, or one we do not recommend, would be to utilize user credentials, for example, create some highly privileged user account. Here I'm using the global admin example to scare us all. And now use those credentials programmatically to obtain a user access token and then make the call. There are several things wrong with this approach. Firstly, in this example, all our app does is enumerates users in the organization, Well, the global admin has way more privileges than that. So we're sitting on a set of credentials that can do pretty much everything in the organization, but we're only doing a little bit. If those credentials were to leak, someone can log in as a global admin outside of our application altogether and do all sorts of things. And another reason for not doing that is you cannot really leverage the app credential management tools and experiences that we have. You'll have to use, you'll have to manage that user account kind of on the side, and that's not a good thing. So Dan is going to walk us through a demo of a provisioning workflow that implements that non-interactive model. And he'll show us some cool additional features of Graph that we will talk about more after the demo. Okay, Dan?
Thanks, Peter. So if anyone's been to our other Graph sessions, you might have heard about Contoso Airlines. And it's just a fake company we're using to demonstrate some of the scenarios that Peter mentioned. So Contoso Airlines, you can imagine, they have a lot of different roles in the company. They have pilots, they have flight attendants, customer support. So they have a lot of new employees coming on. So the scenario we're going to be talking about is the new employee onboarding experience. You can imagine that someone in their maybe IT department, when a new employee comes on, they probably send them a welcome email, share some files with them, add them to the right Microsoft team. So let's see how we can use a background process to automate this entire experience. So they looked at their requirements, and what they realized is, first, they definitely want to send that email. Welcome email, very simple. Then they want to add the new user to a team depending on the role that they are in. So what this means is maybe a new employee is a pilot, and we have a Microsoft Teams team dedicated for pilots to talk about things together. Maybe there's a different team for flight attendants. So what this demo is going to do, it's going to add that new employee to a team depending on what role they are. So to do this, they started thinking about how they can build their app, and they realized pretty quickly this should be a background process, one of those non-interactive processes. So it's continuously running in the background. There's not a user, a human being, signing into an application. So the first demo we're going to do is actually this application is going to continuously pull the Microsoft Graph. You can imagine this is maybe running on a timer where every day, every week, whatever frequency you want, it is asking the Microsoft Graph for some data in Microsoft 365. Who are the new employees in my organization? This is a very simple task for a Microsoft Graph, and this is just an example. You can imagine you could also use the same technique to connect SharePoint to OneDrive or Microsoft Teams. So let's switch to the demo machine. There we go. So what I've done is I've actually already started an Azure function that's running locally on my machine. And here I have Postman, and what we're going to do is we're going to manually trigger this polling process. You can imagine normally it would run like every day or every week, but for the purposes of this demo, I don't want everyone to wait. So I'm just going to manually trigger this sync. So let's see what happens. So I'm going to poll for the new employees here. And if I set everything up correctly, I already have it running in Visual Studio Code, and it hit that breakpoint. So what's happening right now is it's actually calling the Microsoft Graph using our Graph SDK, and it's setting, I'll kind of explain this more later, but it's setting a point in time. So what it's saying right now is when I'm syncing. And then on the following sync iteration, maybe that's a day later, a week later, we can then figure out who has been added only in that time interval, only in that last day or in that last week. So what we're going to get is we're going to get that point in time snapshot, and we're going to save it to a database. So let me play through this. Did not mean to set on that breakpoint. All it's doing is just saving that to the database, and we're going to return a 202 back to the client. And we can see in Postman that our Azure function did in fact return 202. So this was one iteration of that sync cycle. So now what? Well, let's go ahead and add a new employee to our company. So we have a tool. It's free, open source, that's hosted on our website. It's called the Microsoft Graph Explorer. And you can use it to easily interact with the Microsoft Graph. You can try out any query you want, and you can sign in with your own credentials, or you can use the sample account that we already have there. So in this case, I'm going to run a very simple query, and I'm just going to actually, right from my web browser, add a new employee to our company's directory. So to do that, I'm going to send a post request to the Microsoft Graph with some information describing the new employee. So the fake employee's name is Melissa Darrow, and I'm going to increment the email, because you can't have multiple users with the same email address and the same tenant. So I'm going to do a post to /users, and let's go ahead and add this user to the directory. So just making sure, so I created Melissa Demo Day 4, and Microsoft Graph did in fact return Melissa Demo Day 4. So the user was added to our directory, so now let's skip ahead in time, a day in the future, a week in the future, and we have that background process running. Let's see if it finds that new user. So we're going to go back and we're going to manually trigger the sync cycle again. So I'm going to go in Postman, and I'm going to call my Azure function. And you might actually notice here, my Azure function is just running on my local machine. I don't even have it hosted. It's running on an emulator here. So it did hit a breakpoint. And to summarize this code path that it just went down, if you remember from before, we saved that point-in-time snapshot to our local database. So what we did was we actually used that, and it's in a token format. We called Microsoft Graph with that. So Microsoft Graph knew when we started, it knows right now, and it's telling me get every user that has been added since then. So hopefully, we look through here. What we did was we went through every new user in a loop, and we basically ran this onboard method. And inside that, we're going to welcome the new user to our organization. So what I'm doing here is I'm simply just sending an email. And you can imagine there's a lot of different attributes on an email. There's not just the to, from, there's also the subject, the message body, attachments, low importance, high importance. There's a lot of different properties. So instead of crafting that JSON yourself, you can actually use the Microsoft Graph SDK to give you a little bit more IntelliSense and to help figure out the REST requests without figuring out the exact URL. So what I'm doing here is I'm setting the subject. The message body says insert welcome email content here. I guess I didn't get to that. But what we're doing is we're just sending it to that new employee. So let me play through that. We might have hit another breakpoint. We did. So it went through every new user. It sent that email, just welcomed them to our organization. And what we can actually do is, I also signed into Outlook Web Apps, so I can prove it actually worked. We're going to look at the sent email folder and actually verify it did send the email. So you can see this was sent at 8:56 and it's 8:58, so that was probably this one. You can see I actually ran it a few times just to double check. But there's our welcome email, welcome, insert email content here. So we did, in fact, in the background, welcome the user. So this is a really good example where we didn't have a user actually logging into an application like Peter described. We didn't have that user interacting with an app. We didn't use those delegated permissions that he was talking about. We used the application permissions. So in order for this to work, a tenant administrator needed to review and consent to this application. So to review what we just saw, we saw an Azure function that was running theoretically every day on a timer. And it was trying to get what I was calling this delta link from our local database. And that's that point-in-time snapshot. And the first time it ran, there wasn't a delta link saved in the database. It was the first time we ever tried doing this background sync. So what did it do? It actually went to Microsoft Graph and it retrieved one. It called users/delta. And then we got that delta token and we saved it to our local database. And then the next time the sync cycle ran, we did find that delta token. So then we were able to use that to call Microsoft Graph to figure out what users have been added since the last sync cycle. And then for each of those users, we welcomed them by sending them the email. But there was also one other step that you might have seen. When we called Microsoft Graph with that Delta link to see the new employees, we also got back another Delta link. And there's an important reason for that, because now our point in time has changed. So if this runs another week, so 2 weeks from the original sync start, we don't want to welcome the users that we already sent the email to in the first week. So we actually got another Delta token, and we saved that to the database, just overriding the first one. So you can imagine that if you only have a few tenants, maybe less than 100, this isn't too costly. This is running on a timer. It's going to be pretty efficient. You don't have to worry about bandwidth. You don't have to worry about network costs. But imagine if you had thousands of tenants, a multi-tenant application. This might be costly. So there might be another approach, a different way to architect this app that I'll talk about in a minute. But I also just want to reiterate the authentication piece. So before, Peter talked about permissions. Those are like mail.send or user.read. So in order for this application to have access to read all the users in the directory and to see the new users that have onboarded, the administrator needed to consent, needed to review the application and approve the user.read.all permission. A normal user, a delegated user, would not have access to do that. So you might be thinking there's maybe a different way to create this application if you have a lot more tenants and you want to maybe have more real-time access. So for that, I'm going to jump to the next demo. And instead of having our application pull the Microsoft Graph on that interval of maybe every day or every week, what if Microsoft Graph could let our application know when a new user has been added to the directory? And again, this is just a very simple scenario. So what we can do is we can have our application hosted on an endpoint, a publicly callable endpoint. And the Microsoft Graph can ping us every time a user is added to our organization. So therefore, we are not pulling. And this is this could be much more efficient if you're syncing data from many tenants. So both are useful. You just have to use whichever approach best suits the needs of your application. So let's switch back to the demo machine. So the first thing we're going to do is we're going to do what's called creating a subscription in the Microsoft Graph. We are going to subscribe to changes. So in this case, we're subscribing to changes in users. So every time a user is added to our directory, we want to be notified about that. So I have an Azure function. Sorry, 1 second. So we have an Azure function that what I just did was I just manually triggered that. So in Postman, we called the function, and the function called Graph. And we now let Graph know that our application exists and where to call it. So if there's a change, it will ping us. So I think it was just created. So let's go ahead and, just like before, we're going to go to Graph Explorer and create a user in our directory. So let's go back to Graph Explorer. And we can't have users with the same email, so I'm going to increment that to demo day 5. Let's go ahead and create a new user. Yep, and demo day 5 was created. So again, just to recap, this is just Graph Explorer. You can add users any way you want to your directory. I think you can do that from Azure Portal or whatever tool you have. I'm just using Graph Explorer because it's easy for this demo. So let me jump to that method real fast. So what happens every time the Microsoft Graph realizes a user has been changed, a user has been added to our directory, it's going to call this method here. And this is, again, publicly hosted so that the Graph has access to call it. And the method is basically the same as before. We're going to loop through every new user, and we're just going to run through that welcome function. We're going to welcome them. We're going to send the email. But there is one difference this time. Actually, in the notification, in that ping that Microsoft Graph sends our application, it actually tells us some information. It tells us who the new user is. It actually gives us the ID of that new user. So then we don't need to go back to Microsoft Graph to get that information. It gives it to us right away. So let's switch back to the slides. So just to break down the purpose of the second demo, what we saw was we have a function that the first step was we had to create that subscription. We have to let Microsoft Graph know our application exists. But there's another step too, because these subscriptions only last. They're only valid for a few days. So this function, I'd actually have that running on a timer where every 3 days, or maybe every day, it either creates that subscription or it renews the subscription. So it's going to call Microsoft Graph to create it. And then the next step is Microsoft Graph is actually going to call back to our application right away and validate our endpoint. And at that point, of course, we would save that information. So a subscription ID is created, and we'd save that to our database too. And then every time Graph sends a notification that a user was created, it's going to trigger our function, and we're going to do just what we did before. We're going to welcome that new employee by sending them an email. And again, that itself is a REST API call to the Microsoft Graph. So, oh, sorry. There's some people taking pictures. Just give me a thumbs up when you're. Sweet. And I think these slides will be posted too, so feel free to look at them there. And both Peter and myself will be at the booth as well if you have any follow-up questions. So if you see here, the timing was perfect. We hit the breakpoint right there. So where our code is actually stopped right now is in that callback where we created that user in the Graph Explorer, and Graph sent our application notification that the user was created. So this time, I'm actually going to step through this to highlight a few things. So we're looping through all the new users. What Microsoft Graph did was it gave us the identifier of the user that was created, the GUID, but we want to send an email, so what we're actually going to do right away is get some more information about the user. We're going to figure out what their email is. So that's multitasking right now is difficult. OK, I'm just going to jump through all that. But it's the same idea where we're going to loop through every user, get their email, and then send their email. Send them an email. Ah, you heard the ding that time. That's Outlook Web App saying the email was sent. So I'm just going to play through all this. Another ding. I ran this a few times this morning, so it's probably just catching up. OK, and I'm going to remove that breakpoint so we can skip ahead. My next demo is not going to work if it keeps hitting these breakpoints. OK. So my third and final demo is let's make this just a little bit more realistic. So you can imagine, as Peter mentioned, there are tons of services and workloads now behind the Microsoft Graph. And something else that we called out as a requirement in the beginning was let's add the new employee to a team depending on their role. So we have pilots and flight attendants. So what I've done is I've actually created a Microsoft team already in advance, and it's called pilot discussion. So if we create a new employee and the employee is a pilot, let's go ahead and just add them to that Microsoft Teams channel automatically so they're just welcomed right away in the organization. So to do this, I already wrote the code. And I'm just going to comment out these 4 lines right here. And this is very simple. All I did was I created that team just in the Microsoft Teams UI. I actually could have even done that through Graph if I wanted to. And I found the identifier of that team. And this is very simple. I'm just saying if the user's job is a pilot, we're going to add them to that team. And all this is doing, add member async, is it's using, again, that Microsoft Graph SDK that I mentioned before, and it's adding that user to the team. And in Microsoft Graph, teams are modeled by groups, and that's what this call is right here. So because I uncommented those lines, I'm going to save it, recompile, start up the function again. Hopefully this is pretty fast. It's normally under 5 seconds, but this is a demo, so it takes 2 minutes, right? Of course, deleting all the files. I should have told my manager I need a Surface Book 2 just to speed this part up right now. OK, so let's go ahead and jump to Graph Explorer. I'm going to increment this again. I'm not going to hit go because the function's not running. I'm going to wait for it to tell me the function is online. Almost there. So just since I have a little time right now, I'm not actually publishing this function to Azure. I'm actually just running it locally on my machine because networks, Wi-Fi during live demos, that always goes well. OK, so the function's online. So let's go ahead and add that user. So this time, hopefully, it's going to notify our application. It's going to send the email and add them to a team. So we created 6, and it created demo day 6. So we're good. So what I've done in Microsoft Teams is, this is just a demo tenant. This isn't real data, of course. And I created, this is that pilots discussions team. And in here, we're just going to add them to the general channel for now. So let's run. Just to recap, everything is the same. Everything is the same, except for that very last piece. All we're doing is we're adding the user to a team. Well, in addition to sending the email, but everything else is the same. We're on a timer, creating that subscription. We are then receiving the notifications from Graph. So once we have this infrastructure set up, it's really simple just to add on little more bits of functionality. So this is where I say maybe the demo gods are not cooperating right now, but that's OK. Because sometimes the notifications are actually by design not meant to be instant, depending on which service you're subscribing to. If you're subscribing to files being added in OneDrive or users being added in Azure Active Directory, the latency could vary, but it's still definitely faster than always continuously polling Microsoft Graph. So it may take 1 to 2 minutes. That's OK, but I can go ahead and show you, since I practiced this a few times last week and also this morning, what we would have seen, and we actually might see it pop up right now too, is in the team it would say flight team provisioning has added, and then our user to the team. That's what we would have seen. And it will probably happen in about 10 or 15 seconds, but we can keep going for now. So just to recap how the demo worked, I used a lot of different tools. So just to break this down, I used Visual Studio Code. I love it. It's a lean, lightweight editor, super fast. It works on my laptop. I don't need a huge machine for it. And what's really interesting, I actually just found this out when I was preparing the demo. They actually have an extension for Visual Studio Code for Azure Functions. And that helps you not just with local development, but also if you want to then publish that to Azure, it's like 2 clicks, and it was really easy. And then I also used Azure Cosmos DB, and that was just a local cache to save that information. And you saw me using the Microsoft Graph.NET SDK. That was for IntelliSense, autocompletion, so I don't have to make those REST API calls myself. If you want to, that's perfectly fine. But I just chose to use the Graph.NET SDK to help me out a little bit. So also how the demo worked, I used 2 techniques. The first one was Delta Query, and that was how I was continuously polling the Microsoft Graph for information. I was polling for new users being added to the directory, but you can imagine you can also poll for other kinds of information, whether that's files being added to a OneDrive or SharePoint or messages arriving in your inbox. You can poll for almost any, for many changes in the Microsoft Graph. And the first time you poll, you get that Delta token or Delta link, and then subsequent times you call Microsoft Graph with that link, and that determines what content has been added to the graph in that iteration. So this is good for small to medium scale syncing operations. Like I said, if you have less than 100 tenants and you're syncing less frequently, this is probably fine. You don't need to, it's very simple to set up, right? You just have, it's just a REST API call, a get to /users/delta. That's pretty simple to set up. You may run into bandwidth limitations if you want to pull more frequently and if you have many tenants. So in that case, I would more recommend you consider what I showed in the second demo, which was change tracking or change notifications with webhook subscriptions in the Microsoft Graph. So for this, I used the SDK, but if you're curious what the REST HTTP requests look like, this is it. All it was a post call to /subscriptions, and I'm saying, hey, let my application know when there's a change to /users, so if any user is added, And you can actually subscribe to different kinds of events, whether they're created, updated, or deleted. And when a change happens, you actually tell Microsoft Graph where to send that notification. So in this case, I gave it the URL of my Azure function that has been hosted. So there's also, the point of this slide is just to really underscore that there's a little bit more setup involved here. So you have to have that publicly hosted endpoint, but also you have to think about security. And I didn't really cover that in the demo, which is interesting to think about, because if you just have that endpoint publicly hosted, anyone could call you, just like the Microsoft Graph is. Anyone could ping your application and say, hey, this user was added to your directory. Wait, was that Microsoft Graph calling me? Was that someone else calling me? So there is a security mechanism in place that we don't have time to cover here, but it's basically just like an extra token. So when you create that subscription, I save that to the database, and then when I receive a notification, I verify it's actually the same one. And then some of the other setup and maintenance work with this is you do have to always make sure your subscription is active, it hasn't expired, so you want to always renew your subscription. So just again, this high-level advantage to this is you don't have to continuously pull the Microsoft Graph. It's very efficient. If you're syncing lots of data, I highly recommend you look at this approach. Or you can even use both together. That's definitely a valid option. We see a lot of people do that too.
Oops. Okay.
Yep.
Thanks, Dan. So Dan has showed us how to build a provisioning workflow. I want to spend a little bit more time to show you that the patterns that he demonstrated can be used to implement completely different scenarios. So let's talk about an application that we call data loss prevention. That's an industry term for software that scans content of messages, let's say, looking for business-sensitive content, making sure it doesn't leak from the organization. So imagine that Contoso Airlines wants to purchase that from a vendor, and they approach the vendor with the requirements, and the vendor goes through a design process. So what they realize that their application will have to be able to access all mailboxes in the organization. So decision number one, it has to be a non-interactive app the same way as in Dan's case. And the permissions need to allow it to read all mailboxes. But then they also realize that they will need to respond to emails being sent very quickly, and they will have to process a very large volume of emails. And so they realize that change notifications is a better solution than Delta Query, especially if they're going to ship their application to many, many tenants. Polling all mailboxes, millions of them potentially, would not be efficient. So when they look at change notifications, they realize, okay, for Outlook, I'll need to create one per mailbox. That could be millions. So Azure Functions becomes a very good solution to host that creation and renewal process at large scale. Similarly, they realize that handling the notifications for every email is going to be significant. So again, they pick Azure Functions to receive notifications, and they know that as their app becomes more used, they will be able to very easily scale to that increasing volume. So really, everything here is the same as what Dan showed, with the difference being that they will use a different API to actually fetch the content of the messages so they can analyze them. So if I show you that diagram, it's all the same stuff. Our subscription creation, timer base at large scale in this case, and then graph notifications being sent to our function. Our function can fetch them, fetch the full content, and then run the analysis right there in the Azure function as well. Or maybe we can choose to save them somewhere else for asynchronous analysis. But this is where the Azure functions really start to shine when you talk about large volume. So as you now have realized, these background processes and this non-interactive model is very powerful. And specifically, it gives your app access to a lot of data. So what is really critical, and we want to give you some best practices about that, is securing your app, and especially its credentials. So the first thing to realize is that app credentials really mean access to data. Unlike in the interactive scenarios, where if I compromise the app, it's still not good enough because I have to compromise at least some users. In this case, all I need is to get the app credentials. So securely managing your app credentials should be your focus. We recommend you use Azure Key Vault for management, and that you follow best industry practices, rotate your credentials, and so on. If you're developing on Azure VMs, if you're hosting your app or Azure Functions, there's this really cool new feature that I will explain in a minute called Manage Identities for Azure Resources. And the purpose of the feature is to reduce your exposure to credentials when working with Azure resources. The third thing to focus on is data handling policies. Think through what you do with the data, who has operational access to it, and document that, especially if you're dealing with multiple customers who may have different approach to privacy and data handling. So managed identities for Azure, a relatively new feature. Here's how it works. You have an Azure resource, and by that we mean a VM, a function, an instance of app service. You can actually assign an identity to that resource. And after you do that, you can then assign permissions for that identity to access a different resource, I call it a target resource. That could be a Key Vault instance, that could be a Cosmos DB, and many others. Obviously, to be able to do that, I have to control both the Azure resource, my VM, my function, and the target resource, because I'm essentially consenting to this resource interacting with this target resource. Once I do that, any app code that I deploy to running on that VM or function will magically be able to access the target resource without having any credentials. And that's the whole purpose of this feature. So let's walk through how it works with Azure Key Vault and Microsoft Graph. So in this case, this is exactly the scenario we've been talking about. I'm hosting my code in an instance of app services, right there. And I have assigned an identity to that app services instance. And my goal, I have two goals. I want to call Microsoft Graph to do something, but I also want to minimize my exposure to the critical app credentials. I don't want to store them in my deployment. So the first thing I do is I request an access token for the Key Vault. I did the right thing. I put my important app credentials in the Key Vault, but I have to access the Key Vault. And if I store my credentials for Key Vault with my app, well, what good does that do me? Because I can then access the app credentials, and if that leaks, they will be compromised. So instead of doing that, I'm calling this managed identities component without no credentials. I don't know what they are for Key Vault. This component recognizes that this instance of app services is allowed to access Key Vault. So on my behalf, it calls into Azure Active Directory and it requests an access token for that Key Vault. And I get that back. I present that to Key Vault and retrieve my app credentials. I do the right thing here. That's my only exposure to those credentials. I store them in memory. I don't do inappropriate stuff with it. I don't log it. I turn around and I present those credentials again to Azure Active Directory. This time I'm asking for an access token to Graph. Could be something else, but in this scenario it's Graph. And Azure AD gives me that access token, and then I just call Graph as usual. So the key things to note: no credentials for Key Vault in my app, ever, not even in memory, because all of that happened here. And the app credentials for Graph are only traversed through my code in memory. Maybe I cache them a little bit, but that's it. So my deployment is credential-free, so to speak. So these are the key value props of that feature. Reduces the exposure, makes credentials easier to manage, but The key thing to realize is now I have to focus on securing that Azure resource, that VM or that function, because anyone who has access to that and can run code there will have access to all that data. But in some sense, that's a good way, because I can focus on that one thing, and as opposed to multiple places where my credentials could leak. So we hope that you found this useful. We have plenty of documentation for Microsoft Graph as well as authentication using our identity platform. Here are some useful links talking more about the difference between interactive and non-interactive. There's a very large document describing all the permissions in Microsoft Graph and what they do. There are many authentication flows that I didn't go into detail today that you can read about, see which one fits your scenario best. If you're interested in reacting to changes to data, have a look at Delta Query and change notifications. We encourage you to learn about this Manage Identities feature. It has uses beyond Microsoft Graph. It was originally created to make development in Azure more secure. So have a look at that. And if you're interested in the demo that Dan was showing, we have it on GitHub as well. I promised to reference some talks. Some of them happened earlier in the week. You can catch them on video. This is a great introductory talk. This one focuses on those user-centric productivity applications. The one at 10 a.m. today is about specific to Teams. And this is the one I pitched on my first slide, talking about Microsoft Graph Data Connect and those analytic apps that it's fully dedicated to those scenarios. If you're new to Graph, here are some useful resources. Stay tuned on Twitter for announcements. GitHub location for all sorts of samples on different platforms. And if you have problems or questions, you can use Stack Overflow with Microsoft Graph Tag. What we haven't shown here is that we recently enabled user voice location for Graph, so we're getting a lot of traffic there. So if you have feature asks, that's the best place to go. Thank you. We have 2 more minutes. If there are any questions. Can you please use the microphone if possible, because this is being recorded. So, and Dan and I will be at the expo floor at the Graph booth. We have a whole alley for different Graph components.
Yeah. Hi, I'm Paolo from Italy. Basically, I have a question on Delta links. Mm-hmm. We are heavily using the incremental changes for groups and users on our application every 3 minutes. Huh? We are on a multi-tenant. But for big tenants, basically, the Delta token is shown only on the last page. And sometimes, with a default an hour token, you cannot reach that token. Mm-hmm. You know?
Yes.
Also, when you reach the token, on a day, a big, huge tenant can do a lot of changes. So, in an hour default token expiration.
So I think what you're talking about is that your access token expires, yeah, but the Delta link is valid. It's not tied to an access token. So a Delta link is valid for case of Azure AD for 30 days or more. So if you refresh your access token, you can continue to, you can still use your Delta link. The problem you're talking about, like the first enumeration of the entire state, because like Dan showed, with Delta, you kind of pull the whole state, and then you do incremental queries. There's a clever pattern in Azure AD you can use where there's a
next page link.
No. There's a parameter that you can say, I don't care about the current state. I just want the Delta link from now.
Yeah.
So you immediately get a Delta link.
Yeah, we're using that.
Right. And then you can get the current state separately by not using Delta. You can just page through all users.
Yeah, but my real question is if it's correct in some cases when we cannot reach the Delta link, right, if we can store that on a temp fashion like the next page link. So from the next round, we can start from the next page.
Yes. And if
Makes
you
sense,
refresh,
yeah?
if you refresh your access token,
No, without refreshing the access token, with creating a brand new one.
correct.
Yeah, so we can start from the next page link to
Yes,
reach. Okay,
correct.
thank you very much.
You're welcome.
I had a similar question maybe. So when I have a delta link and I use the delta link, I get the next delta link. So are the previous delta links valid? And if so, how long they're valid?
They're valid for 30 days. It depends on the service. Again, we're trying to maintain a common protocol across Graph, but it's really the individual services that implement all these APIs. So in Azure AD, it's 30 days, I believe. But yes, the previous one will work. They're not tied together.
The last question I had was there are a few endpoints in the Graph APIs that are with /me,
Yes.
meaning you use that endpoint as some user right. So can the application registration in the non-interactive flow use that API by mimicking the user somehow? Because some endpoints only have the /me, they don't have the capability to add like /user/ID.
I don't think that part is true, but we can discuss later. So the /me is just a trick. It's like a syntactic sugar to not have you write user/ID. If you saw in my examples, for that reason, I was always saying user/ID. When you say me, all you're saying is, hey, Graph, just look at the user token and figure out who the user is and replace me with user/ID. But so in an application-only mode, that doesn't make sense because there is no me. But I'd be surprised if what you're saying was true, but I'm curious to find out if there are actually APIs, because I believe this is handled at the gateway level completely in Graph. This
I'll sync up with you maybe after
Sure.
and we can go. Thank you.
One more? Sure. We can go for as long as they don't kick
My
us
name
out.
is Oleg. I'm from Quest Software. We are working on directory related things, Azure AD, and mostly would like to enumerate accounts, users, groups there. And we were trying to use Delta query with directory objects, so getting
Yes.
all types of objects like users, groups
Correct.
in a one request, Delta request, and it wasn't possible at least last year. So we need to do Delta queries for users, groups, service principals, all other stuff
Yes.
that is available.
So you can do it two ways. You could have independent Delta queries for each type.
it is additional requests and
Correct,
we need to
correct.
store this
So there's a problem with that because you're managing many more. It might it will reduce the size of the response. But we have added a capability on directory objects. It just doesn't support all the types yet. Because we used to have it in the previous API called Azure AD Graph,
That's right.
right? It was like a generic, like get changes to the whole directory. So we're trying to bring some of that into Microsoft Graph because customers have asked for that. And we have added it, but it's not fully functional in the sense of what it can enumerate at the moment. Unless there are any more questions, I think we're going to. Okay. Sure. Maybe we can take it offline because I think there are people coming in for the next session. So thank you very much. Bye. Thanks.